have it because I'm host. Oh, you do too.
Okay. So welcome to lecture number, I can't remember, but this is CS Module 2. So I have a few somewhat longer announcements today. To begin, coming up, CS Module 2 is due Sunday. This time, there's a bit more reading, so it might take a bit longer, just as a heads up. Your third group meeting will be this upcoming Thursday. And next Tuesday will be the mental wellness workshop. And the workshop is intended to be interactive and more of a discussion, so we will be having a checkoff for that workshop. This workshop, we will not have a checkoff, attendance is not mandatory, and we'll be recording this in case you miss this or you can't attend or something like that. A few miscellaneous announcements. So the physics department is hosting a panel on traditionally underrepresented groups in physical scientists. There's going to be a lot of cool professors, graduate students, postdocs, and attending. So I encourage everyone to go take a look. In election news, if you are able to and haven't already, please register to vote. California's deadline to register to vote by mail is October 19th, so just under 2 weeks. If you're out of state, you can find resources online on how to vote in every state. Additionally, Election Day is not recognized by Berkeley as a non-instructional day. ulab itself will be making plans, so we'll be moving lecture or other pre-recording lecture and moving office hours to accommodate for Election Day. And if you believe that it should be a non-instructional day, you can feel free to check out the letter that I believe the Cal Democrats have drafted. Link is also available, I think, on Slack or somewhere else. As I'm sure you're also aware, the Nobel Prize for Physics was also awarded today. So very exciting. Just as a brief overview, the prize was awarded to 3 scientists: Roger Penrose for discovering that black hole formation is a robust prediction of general relativity, Reinhard Genzel and Andrea, I'm not quite sure how to pronounce that, but Jez? Something like that.
Yeah, I'm not sure either.
For the discovery of supermassive compact objects at the center of our galaxy. Personally, I only vaguely understand what that means, but if you're interested in any of those topics, I highly recommend talking to your mentors, professors, and that sort of people. I'm sure they have a lot to say on this. I think this year's announcement is particularly exciting for 2 reasons. For one, Genzel is a professor at Berkeley. He's also the director of the Max Planck Institute for Extraterrestrial Physics. Andrea is the 4th woman to win the Nobel Prize in Physics out of about 216 total, so that's a somewhat depressing statistic. And so in response to that, I've had a quote from her, which I'm just going to read. She says, "I hope I can inspire other young women into the field. It's a field that has so many pleasures, and if you're passionate about the science, there's so much that can be done." Hopefully that's a bit inspiring. And with
Another
that,
cool thing. Sorry, were you?
I was just about to end.
Yeah. I'm also going to take this opportunity to plug the physics department colloquiums, because the previous latest woman to win the Nobel Prize in Physics was Donna Strickland, who won the prize in, I believe, 2018. And she came to Berkeley and gave a talk about it. Like, I believe it's a common thing for new Nobel laureates to just go around giving talks at the big universities. So that included Berkeley, and I got to go to that talk as a sophomore, which is a really cool experience. I understood about 10% of it, but what I did understand, I was very fascinated by. So I believe colloquia are still happening virtually, so you should absolutely go check that out. They're really, really interesting, and they might just set you down a path for like a lifelong research interest or career.
Yeah, that's a very good point. The next physics colloquium will be on the 12th, which I believe is next Monday. And I'll try and find the information for you guys and post it on Slack. Speaking of the Donna Strickland lecture, I have a really interesting story of how I embarrassed myself in front of her in that very lecture. So if you guys are interested, come to office hours and maybe I'll tell you my embarrassing story sometime. Anyways, back to CS.
I'm going to take over screen sharing now. So the way today is going to run is I have loaded this blank Jupyter notebook, and I'm going to just start typing in here. We're going to follow roughly the material that you'll be doing in CS2. but this is pretty free form. So if you've got suggestions for like something I should try out and we'll see if it does something different, or we'll see if it throws an error or something, feel free to shout those out or put them in the chat, and Che is going to be watching the chat for questions or those kinds of comments. And so ideally this is driven by you guys as much as by me. Okay, so the content we're going to be covering that's important for the module is, there's roughly three big concepts. One is conditional statements, one's loops, and one's functions. And these are all like sort of the bread and butter of how Python works and how a lot of programming languages out there work. So what you've seen already is the very basic part of Python is it's a calculator, and I can do like simple computations that'll give me a result. And this, of course, you saw in CS1 already, that I can do these kinds of simple computations. Additional things like modulo, which gives me 12 divided by 2 has 0 remainder. And it's also a calculator with memory. So I can equally say A is 12, B is 2. I can ask what A is, ask what B is, say C is A divided by B. And then I can ask what C is, and that's 6.0, 6 as a float, which is also a distinction we talked about in CS1. So that's like the basic level we're working with. Today, what we're going to cover is more, how do we make it do things we want it to do? How do we do things that are more advanced than this calculator with memory functionality? So the first of these three structures we're going to talk about to do advanced things is the if statement. So the way that works is I type out if some condition. So let's say if b is greater than 3, print b is large. And so right now, if I run this, any thoughts on what will happen? It's pretty readable, just like you would read text normally. So
I don't think it's going to return anything.
okay, so we have it's not going to return anything. Anyone think anything different? Seems like no. So let's run this, and we see it indeed doesn't do anything. So that's because it went through and it evaluated the statement b greater than 3, and it saw it was false. So it didn't do the thing I asked it to do if it was true. If I change this to 1 instead, I know b is 2 from up here, and it does say b is large. So just to unpack what's going on there a little bit more, is there's a few steps involved in this process. Steps in evaluating an if statement. One, Python looks at the condition after the if and before the colon. Python evaluates it to a true or false. If we have true, run the next block. Run the indented next block. All right, so what does it mean to evaluate it true or false? We can see that just from running this part alone. If I just take b greater than 1, then that's going to give me true, and I can run b greater than 3, and that'll give me false. And so if takes in only these two things, and things that, you know, are complicated and can be simplified down to these two things. So like if and Python also has the strange quirk that I can put things that are not just true and false in here. So I can put in, for example, if b, print b, and b is something. I don't know what that something is yet, because it's not entirely clear what it would mean to do this. So we know that b is the something, which b has sort of like truth to it, but it's not itself true because, you know, it's the number 2. So what we'll see, if you dig into it a bit, is what that's actually doing is calling this built-in function bool on b, and it's returning true. What this does is it takes a bunch of different data types and condenses them down to, are these essentially true or essentially false? Or you'll see this sometimes as like truthy or falsy. data types in Python are inherently true or false, and we can see which one they are by using bool. So for example, 1 is inherently true. 0 is inherently false. The string is inherently true. The empty string is inherently false. So you can get sort of a sense for these by playing around with it a little bit, but the general pattern is if it's got something in it, it's usually true. If it doesn't have anything in it, it's generally false. Okay. The if statement can be a little bit limiting because sometimes we want to run something in one case and another thing in another case. So let's just go back to this example up here where b was large and say, if I wanted to do something in the case that b is less than 1, I would add the else statement here. So in this case, b is large. And let's say I went over here and changed b to 0. Now b is 0, and I can rerun the cell. And it's going to tell me it's small. It evaluated this, saw it was false, and so it jumped to the else part of it. Okay, so far we've covered just if and else. Does anyone have any questions on that? Seems like we're all good. I saw a couple shaking heads indicating you're all good. Okay, so from here, we're going to turn to one of the classic intro software engineering questions, which is something called FizzBuzz. And you can Google this later, and there's videos on it and things like that. But essentially, the challenge of FizzBuzz is I want to print out all the numbers from, let's say, 1 to 20, except when something is divisible by 3, instead of the number, I want to print fizz. Instead of when it's divisible by 5, I want to print buzz. And when it's divisible by both, I want to print FizzBuzz. So I'm going to make a for loop over here, and we'll come back to this in a minute. Like after we're done with this, we'll go to what I'm doing over here and why. But for now, just see that this gives me all the numbers to start with. It gives me 1 to 20. And now we can start adding if statements to this. So maybe I start with like, if I divide by 3 is 0, print fizz. If I divide by 5, 0, print buzz. And this seems to like fit my description that I gave before, right? It's if it's divisible by 3, meaning the modulo I modulo 3 is 0, I'm going to get print fizz. If it's divisible by 5, I'm going to print buzz. And if it's neither, I'll just print the number itself. Does everyone agree with that? Okay, I actually tricked you a tiny bit. You shouldn't agree with that. And let's see why. So over here, there's a couple problems with this between this output and the description I gave you of what this should do. Any thoughts on what? You can put it in the chat as well. Chair's watching the chat and will let me know if someone's saying something there. So if you don't want to speak up, that's totally fine. You can also DM Chair if you have an answer.
Right now I see that instead of replacing the numbers that we're taking the modulo of, we're printing the value and then printing the number. Is that what you're going for, or are you going for something else?
That's one part of it, yeah. There's multiple things that are off about this, and that's definitely one of them. Thank you. Right, so what we want here is, if I'm printing fizz or buzz, I don't want to also print this number here. So does anyone else have a suggestion for how I might fix that? And I'll just scroll up and show you what we did up here, so you can get inspiration.
Could you just write else?
Okay, that's right. Where do I want to write else exactly?
you like in the same line as if. Column,
Which one?
not line, column.
Yeah, the same column as if. So that's back here, and below the ifs over here. Else, print I.
Yes.
Now let's see what
I don't know.
happens. Okay. So now it seems like if I've got a fizz or a buzz, I shouldn't be printing I because that's the else block. So that seems good. Let's try that. Okay, now do we like this output? The hint is you still shouldn't like it. There's still a problem.
I don't really know how to fix this.
Okay, well, it's okay if you don't know how to fix it. Just, I'm seeing Andrew in the chat a little bit ahead of me. I haven't introduced Elif yet. That's what I'll do in a minute. That's good. But Pablo, can you tell me, like, even if we're not sure how to fix it, what's wrong with it? What do we want to fix?
It's just not working because sometimes it's different to those options. I don't know.
What's different exactly?
Well, I'm so confused.
Okay. Well, that's all right. So I'm seeing Tobias in the chat saying we want to make it print both under oaths divisible by both. And yeah, absolutely. That's another change that we'll make. But for now, I'm going to address the problem that Andrew brought up. So Andrew, could you tell us why I want to change this to an elif? And then I'll go into what an elif is.
So my understanding is the if statement runs in series and not in parallel, so that when it goes through the first if, it will still go through the second if. However, if you change if to elif, it then runs in two parallel. So if it runs through the first if, it doesn't go through the second statement. That's my understanding.
Yeah, that's exactly right. So what's happening right now is this isn't a single if block. Like up here, I wrote this whole thing as a single if block, but what I've written down here is actually two different if blocks. So really, a more faithful representation would be this, with this like space line in the middle. So this is our first if block, and it's printing fizz if it's divisible by 3, and this is our second if block. So I want to combine these into one thing. If essentially the functionality I want over here is a first if, then I want to do else over here, and then this whole thing. So like I want to only run any of this if this one comes up false. But it might get a little cumbersome to like keep doing this. You could imagine a case where I've got like 10 things I need to do, and I would just keep like indenting and indenting and indenting and indenting, and the program would just go crazy. So this isn't really practical. This is how some languages do it, actually. Some languages only have like else if, and they usually let you do like this so that you have it only on one line. But how Python does it is it condenses this else if into the single word elif. So now what will happen is I'll run here. If this comes up false, I'll check this one instead. And I've got this like sub if without having to do more indenting. And then if that also comes up false, I go back to print I. Let's run this one now. Okay, now this is looking a lot better, but we're still running up against the problem that Tobias mentioned. Tobias, do you want to tell us what that was? It's changed a bit now, but what was it?
Pretty much the problem is that we want to print like fizzbuzz as one word if you encounter a situation in which the number is divisible by both. Right.
And earlier that wasn't happening because it was printing fizz and buzz separately because I had these two separate if blocks. Now I've got one if block, but when I hit a multiple of 15, like over here, I'm just stopping when I see it's divisible by 3. And I want to print out the word fizzbuzz, like I've got it up here, both of them together. So does anyone have thoughts on what I can change to get that functionality? My cursor position's a hint here.
Yeah, I was going to say you could add another if statement before your top one and then change that lower if statement to another elif. Mm-hmm. And then if you make your first, when like if statement, have the condition that both are satisfied, so divisible by 3 and 5, then you can tell it to print fizzbuzz, and then if that doesn't happen, it'll pick one or the other, or just print the number.
Right. That sounds really good. So what I want over here is something that says both of these are true. And I can just do that. Syntax varies on how you do like this and that in languages, but in Python, it's really simple. It's just the actual English word and. So I can just do this. And there we go. Now we've got all the functionality we want. 1, 2, fizz, 4, buzz, fizz, and so on like that. And you see it just hits fizz buzz instead of 15. And it doesn't print out the number 15 or fizz or buzz separately. It just does exactly what we want. All right. Another note is, another way of writing this is I could just say the single statement, I divisible by 15, because 3 and 5 happen to be both prime numbers. So if something is divisible by 15, it has to be divisible by 3 and by 5. And so that's entirely equivalent, and which one you pick is dependent on like, what are your specific needs? Maybe will I need to change these numbers later? So just to go on about that, sometimes it's good practice to assign these to variables over here. So instead of the 3 and the 5, I'll just say f and b. And so that's got the same behavior, just because I've just set these to variables, I'm using the variables instead. But now suppose I wanted 2 and 5 to work. I just change this number 3 to a 2 up here, and my program works with these other inputs now. So that's a really good general principle that you should, whenever you have this kind of global information that you might want to change later, you should put it in variables instead of like hard coding in the numbers. All right, does anyone have questions at this time? Seems like no, that's great. Okay, next up, we'll be dealing with loops. So I already touched on loops a little bit up here, where I made this for statement that just gave me the numbers 1 to 20 in order. But I didn't really go into the details of what I was doing there. So let's do that now. For loops and while loops are the two types that we'll deal with. Loops, for, while. And both of them essentially say, do something over and over again. Like if I want to print out, for example, like I believe something on your CS module 1 was print out 1 mod 2. That. Let's put is in there as well. Yeah. Comma, so you don't need the space there. And then you can do 2 mod 2 is this. 3 mod 2 is this. I believe you had a block that looks something like that. That should be a 3. If you wanted to do that for all the numbers 1 to 100, you'd have to write this out 100 times, and that's really annoying. So instead, what you can do is I can say, I'm going to start a variable. I'm going to call it I is the usual like index variable, and then usually go to like j and k after that, but that's just a convention. You can set it to whatever you want. If I want to do this for 1 to do this for 1 to 100. If I want to do this 1 to 100, what I can do is this. I could say, I'm going to set I equals 1. And then I can set up a while statement saying, while this condition is true, I'm going to just keep doing this block over and over again. While condition, and I'll fill in condition in a second. Actually, I'll just fill in condition now to be while I less than I max, or I set I max to 100. And I make this print statement. So I made a mistake there. Can anyone tell me what?
You're not incrementing your I.
Yeah, exactly. So this is a distinction between for loops and while loops that we'll see in a minute. Up here, all I had to write was, first let's end this computation before I just kill my computer printing out 1 mod 2 is 1 a million billion times. Yeah, that stopped. Up here, all I had to specify was this range, and it'll just go through each one, and I don't have to explicitly do the incrementing. With a while loop, and this is, again, a common trait to a lot of different languages, you do have to specify how I'm changing y. So right now, what I'm doing is, I'm doing 1 mod 2 is 1, and then it's saying, okay, I'm done. Let's go back up here. 1 is less than 100, sure. So I'll print this again, 1 mod 2 is 1. Let's go back up here. 1 is less than 100, that's fine. So what I want to do here is, I gets the value I plus 1. So now I go through this, I evaluate this right side. This is 2. So this is basically I equals 2. It goes up here, it says 2 is less than 100. So it goes again with 2 mod 2 this time. And actually, just for the demo, let's set this to 20, just so we can see all of it. And here we get it actually stopping. It's actually stopping at 19. And to make it stop at 20, I can just make this less than or equal to. And there we go, 1 to 20. So that's a bit on the functionality of a while loop. It says, while this condition is true, I'm going to just keep looping. I'm going to do this over and over and over again. Sometimes you do actually want it to do it infinitely, just because you've got some other like failure state in your program. And in those kinds of cases, you can just say true directly. Remember that like I'm evaluating this and it's either true or false at every iteration. So in this case, if I run this now, it'll be false because I stopped at 21 and Imax is still 20. So that means this is false right now, and that's why I got to break. But if I want this to just always be true, I can just say while true, and there's no way that can stop. And that's useful sometimes, but it's always a good idea to know when you're stopping. It's more often a good idea to know when you're stopping. So that's while statements. Now, for loops, there is a lot that can be said about them that we'll come back to when we've done lists and more general iterators. But the form of a for loop that's useful for us is this kind of statement. For I in range 1 to 21, which is the statement I had up here when we were talking about FizzBuzz. What this does is essentially the same thing. And let's make this a markdown cell, actually. So I can just type this in text, equal to, this is the same as I equals 1 while I less than 21. And let's say I'm doing something. Do something here. And also I equals I plus 1, which I can also write more simply as I plus equals 1. Should surround those with triple quotes that we read them as. Whoop. Okay, turns out I do not remember how to do this in Markdown, but never mind. So the for loop for us right now is just going to like have the same functionality as the while loop, but it's going to be a little easier on us to type. So the two numbers I'm specifying in this range are where I start and the upper limit of where I end. So 1 to 21 gives us 1, 2, 3, 4, all the way up to 20, but not including 21. By default, I can also just provide one number. And that's going to actually start us off at 0. So you'll see here, the difference is I started at 0, and then I went up to 19, not including 20, not including the upper limit again. So let's now use this notion of a for loop to do a useful thing. Compute the factorial function. So the factorial, which is hopefully familiar, is this thing that just takes the product of all the numbers below you up till down till 1. So let's say I'm going to set n is 6 over here. Let's start writing this factorial. What's one really easy way to do it? say I've just asked you for 6 factorial. Like, don't worry about generalizing it yet.
Would it be 6 times 5 times 4 times 3 times 1 times 2?
That works, yeah. And I asked for n fact, it gives me 720, which I know is right. So that works, kind of. But like, it's really annoying to write all these out by hand. And if I wanted like 100 factorial, I wouldn't be able to do that. And like, without writing out 100 numbers. So I've got something that I'm doing over and over again. Seems like this is a good candidate for a loop, right? So let's try and write a loop together to compute the factorial of n in a way that actually works for us. So I'm going to give us a bit of a skeleton. All right, so I'm telling us that we're going to start off with some value for n fact, and we're going to run a loop, and we're going to update it somehow. Any thoughts on what can go where?
Initially, n fact should be 1, and in the range, we should put 1 n plus 1.
Yeah, that sounds really good.
And
could you tell us why?
Because you can't times if you time anything to 0, then the whole thing will become 0. So n fact couldn't be 0 and it should be 1. And in the range, because we start as 1 and then we end, we want to end as n, but the range, if we do I n, then we'll end as n minus 1.
Yeah, that's really good, because I want to end at n, so I put in 1 more than I need. Or another way of writing that would be, well, I'll show you in a minute. What should go in this line over here? The one where I got n fact equals something. So remember back up here where I was setting I equals I plus 1. Let's try and do something similar here.
Equals n fact times I.
N fact times I. Sorry, who is that? I can't see your face right now.
It's Yongshi, because I turned off my camera.
Okay, right, thank you.
Sorry.
Right, so let's see if that did the same thing. I asked for n fact, it's still 720, but now I can change this to 8, and it gives me 8 factorial, so that's great. Another way, if I don't want my range expression to be that complicated, is I can just say it's n, and I'll just make this an I plus 1 instead. And that's still the same thing. And now I can even go up to like a really crazy number. And that's long, and that's probably difficult to use in computations, but you can do it. I just did 100 factorial without like changing very much at all. All right, so that is your primer on loops. Any questions? Seems like we're good. Okay. The third thing we're going to be discussing today is functions. Should really make these like bigger markdown headers, like that. So far, what we've been doing in this notebook is we've been like adding little bits of code here and there, just in these individual cells and trying to use them later. Like up there, I set b equals 2 from when I did the FizzBuzz example. So if I ask for b now, right, that's sort of the problem because I didn't remember that. It is actually 5, and that's because I changed b later to b. B is 5 over here. And initially I had b is 2. So you see how it gets pretty confusing, as I just very convincingly proved to you. It gets pretty confusing when you've got like a bunch of variables that can all mean different things, and they're all in the same scope. And scope is a more technical term, but essentially it means like, if I was doing something up there with FizzBuzz, it shouldn't necessarily affect the output that I see down here. I want to like separate out pieces and keep everything nice and clean. So if something breaks in one part of my program, it's not going to break everything downstream. I can just fix that one part. So functions are the way we make these little parts that we can put together. And the syntax for making a function in Python is def func name, or that's just function name, argument 1, argument 2, like that. I'll just put in argument 1, argument 2. And then in here, I can do whatever manipulation I want to these arguments, like the same way I would up there. Like argument 1 equals argument 1 plus argument 2, maybe. Return argument 1. So that's something, it's a little bit, it's written a bit in a cumbersome way. Like I maybe just call these A and B, but just for the sake of seeing what's what. So this is a function that will take in two things, add them, and return them. It just does A plus B. So let's try and use our function. Let's call it simple add. A, B. A is A plus B, return A. And this is a little bit redundant because I could just say return A plus B, but just for the sake of seeing the return statement. Return just says, when I call this function, I want the output to be this thing. So I can do 2 plus 3, and that'll be 5. And I can also simple add 2 and 3, and that will also be 5. But then, of course, you've seen the advantages of like being able to change things later. So maybe I want this to do multiplication for whatever reason. And then that function will be 2 times 3 instead. So let's change this back to addition, just for the sake of showing this off. And notice over here, I can like assign something to the output of a function, same as I could over here. I could say like C is 2 plus 3, C is 5, C is simple add of 2 and 3. And so that works the same way. And a lot of the things we've been using, like the type argument, the bool thing that I showed you above, these are all functions as well. They're just functions that Python gives to you. So this is your way to add on to that infrastructure for yourself. It's really good for encapsulating things that you don't want to affect downstream changes. So for example, we could have put that whole thing of fizzbuzz in a function. Let's do that. Instead of B, 2, and 5, I can do this. And when I call this, it's not going to do anything because I've just defined it. I haven't called it yet, but I can call fizzbuzz of 3, 5, and it'll give me the output I got before. I can do fizzbuzz of 2, 5, it'll give me the modified output it gave me before. And maybe I also want a parameter for like n max. So quick change I'm making there is I'm now passing in another argument with a default value, which means if I don't specify it, it'll just go with the default. But if I do specify it, it'll use this updated version. So that's really useful when you've got like different use cases for things. Functions can be used to encapsulate things, but they can also call functions from other functions. So not this one actually, because all this one does is a bunch of printing. But let's say I made this new function to check I want to check if a string starts with a certain character. And I'm just going to implement this very simply of this. And you'll learn this indexing notation that I'm doing here in, I believe, CS3. But right now, it suffices to know that I've got this function. And it does this. It tells me the first letter of ulab is actually U. It's not C. The first letter of class is not U. It's actually a really useful property of functions that you don't need to know everything that's going on with them. If you've got a good description via a docstring, which is something there right, like this, if I've got a good description of what a function does, I don't necessarily need to know everything that's going on in there to be able to use it. And this is sort of the principle that you're already using with like, I don't need to know how type and bool are doing their thing. I just need to know that they work. And that's really useful when you're trying to deal with something with a lot of complexity that you need to spend time to understand. Okay, so what we've got here is a function that checks if a certain string starts with a certain character. Now let's try and call that from a different function. Check longer check phrase. Now over here, what I want to do is I want to take a whole phrase, a string with commas in the middle, and checks which ones start with test car. So basically I want to do this thing, but on a whole bunch of words at once. And once again, I'm going to use some functionality I haven't shown you yet, because for the sake of functions, it doesn't really matter. It matters that you know how this works more than you know how every little thing on it works. It's a really powerful idea of like abstracting away those details. So let's say for word in test split check if starts with word test car. So I'm just having this print everything. And so I've defined this other function that uses this function that we defined before. So let's start check phrase starts. I actually maybe want to make this split on just spaces so that I can just put a full sentence there. ulab is, someone give me another word starting with U. Come on, this is a really easy interactive one. Sorry, I think I heard a bit of noise there. I didn't quite catch that. Okay, I see in the chat, useful. Useful is a good one. And awesome. So over here, I want this to give me ulab and useful. Well, that's not what it's going to return. Actually, what it's going to return right now is not terribly useful. Can anyone tell me what it's going to return?
It should return 2 trues and a couple of falses. Yeah.
Okay. So that's actually a slight trick question. It is going, and this is a subtle difference here. It's going to print those things. It's going to print, whoops, looks like I forgot something. Yeah, I forgot the U in this call here. And that's an error, and you'll be dealing with errors on the module as well, so I'm glad I made one mistake. It's just going to print, wait. Something's going strange here. So it's splitting it just fine. So this is a little inside my debugging process, impromptu. Ah, there we go. I just hadn't rerun it. So I got ahead of myself just a little bit there. That was the next thing I was going to show you. So it gets me true, false, false. That's not a really useful output because I don't know which ones are true and which ones are false. So any thoughts on, this is a more open-ended question just for the last couple of minutes here. Any thoughts on how I can make this more useful? Think back to stuff we did earlier in this lecture.
I mean, just to be clear, what is our goal?
Well, our goal is just to get a generally useful output of like, I want to know which words start with U in this case.
Okay.
And that's a slightly open-ended question. I didn't specify like, you have to meet these exact requirements. It's a little more of a creative problem, which is definitely the kind you'll deal with when you're coding.
Mm-hmm. Well, if nobody has a suggestion, throwing an if statement in the middle of your for loop in your function to check whether or not we're getting a true value for our word is probably going to be a little bit more useful. So like if it's true,
that is definitely going to be useful. So one thing I was thinking that I did by accident a little early was print the word and then print true and false. So I got ulab, true, is, false, useful, true, and false, awesome, false. But you could imagine that doesn't scale very well. If I've got like a really, really long sentence, then I don't want to look at like 1,000 lines of output of trues and false in words. I instead just want to print the words that do start with U. So we'll use Gianluca's great suggestion of instead using an if statement over here, like we learned about above. And maybe if it starts with the letter we want, I print the word and don't do anything otherwise. So now I just get out ulab and useful. And one more time, we see the utility of like first functions and second setting things to variables that you just change on the fly. Because now say I wanted all the words that start with A, I can just change that U before to an A and it'll run the same thing, but I don't have to rewrite this whole thing. I didn't have an A in here, for example, which would work here, but then I changed it back to U and it doesn't work anymore. Instead, I have a name for it and I use the name. So that's a lot on the utility of functions. Okay, that is all the time I've got. I'm happy to stick around for 10, 15 more minutes for any lingering questions or if you'd like me to demo anything else, but you're free to go at this point.
great lecture today, man. Have a good night.
Thank you. You too. And one more thing is I'll be posting this notebook somehow, probably on B courses. Yeah. Let's stop the recording.